The USS Gerald R. Ford is more than just a ship. It is, honestly, a floating piece of American territory. A sovereign fortress navigating the world's oceans with purpose and power. Designated CVN-78, she is the lead ship of her class, the first new aircraft carrier design in over 4 decades. When you see her silhouette on the horizon, you are witnessing the physical manifestation of naval supremacy. Displacing over 100,000 tons, she is the largest, most powerful, and most technologically advanced warship ever constructed by humankind. Her sheer scale is, well, difficult to comprehend. Her flight deck, sprawling across 4.5 acres, could comfortably house several football fields. This is not merely an upgrade, it is a fundamental redefinition of what a capital ship can be and what it can achieve. Her existence is a testament to engineering ambition and military foresight. From keel to mast, every plate of steel, every mile of wiring, and every integrated circuit has been designed for one overarching mission: to project power and secure the seas. The Ford represents a quantum leap from the Nimitz-class carriers that preceded her, ships that were themselves the undisputed queens of the ocean for generations. But progress waits for no one, especially in the unforgiving realm of global defense. The challenges of the 21st century demand a platform that is faster, more efficient, more lethal, and more resilient. The Gerald R. Ford is the nation's answer to that demand, a vessel built not for the last war but for the next one, and the one after that. The name she bears is significant, honoring the 38th President of the United States, a man who served his country with distinction in the Navy during World War II, aboard the light aircraft carrier USS Monterey. This legacy of service is ingrained in the very soul of the ship. She is a symbol of continuity, carrying forward the proud traditions of the U.S. Navy, while simultaneously pushing the boundaries of what is possible. Her crew, numbering over 4,500 sailors and aviators, are the inheritors of this legacy. They are the lifeblood of this steel behemoth, the dedicated men and women who transform this marvel of engineering into a living, breathing weapon system, ready to answer the nation's call at a moment's notice. Walking her decks is like touring a futuristic city. The vessel is a self-contained world, capable of sustained operations for months on end without needing to see land. She generates her own power, purifies her own water, and houses a community of thousands. But unlike any city on land, this one can move at over 30 knots, repositioning an entire air wing and its support infrastructure anywhere on the globe. This mobility is her greatest strategic asset. She is a mobile airfield, a command center, a logistics hub, and a powerful deterrent, all rolled into one colossal hull. The USS Gerald R. Ford is the point of the spear, the ultimate expression of naval aviation and a clear signal to allies and adversaries alike. At the core of the USS Gerald R. Ford's revolutionary design are 2 A-1B nuclear reactors. These power plants are a marvel of modern nuclear engineering, smaller yet vastly more powerful than the reactors found on the Nimitz-class carriers. They generate an almost unimaginable amount of electrical energy, nearly 3 times that of their predecessors. This surplus of power is not for luxury, it is a strategic necessity. It is the lifeblood that feeds the ship's advanced systems, from the electromagnetic catapults to the sophisticated radar arrays and the future energy weapons that are no longer the stuff of science fiction. This electrical capacity is the foundation upon which the Ford's entire technological superiority is built, providing the energy needed to dominate the modern battle space. This abundance of power enables a new level of automation and efficiency throughout the ship. Many of the systems that required large teams of sailors on older carriers are now managed by smaller, highly trained crews using advanced computer interfaces. This reduction in manpower by several hundred sailors compared to a Nimitz-class carrier is not about cutting costs. It is about optimizing performance. A smaller crew means less strain on resources like berthing, food, and water, allowing the ship to stay on station longer. It also means that each crew member is more specialized, a highly skilled operator at the nexus of human and machine, ensuring the complex systems work in perfect harmony. The ship's internal design has also been reimagined from the ground up to improve workflow and sortie generation rates, the speed at which aircraft can be launched and recovered. The flight deck layout is optimized, with redesigned aircraft elevators and armament staging areas located closer to the action. This might sound like a simple logistical tweak, but in the high-stakes world of carrier operations, every second counts. The ability to rearm and refuel aircraft faster translates directly into more combat power being projected more quickly. The Ford is designed to generate a sustained sortie rate that is nearly a third higher than previous carriers, a decisive advantage in any conflict. Beneath the flight deck, a network of advanced systems works silently to keep the city at sea running. Plasma arc waste destruction systems turn trash into energy, reducing the ship's environmental footprint and logistical trail. Advanced water purification plants can produce hundreds of thousands of gallons of fresh water every day. Every aspect of the ship's support infrastructure has been modernized to enhance self-sufficiency and operational endurance. The USS Gerald R. Ford is not just a platform for launching aircraft, it is a fully integrated ecosystem, a masterpiece of engineering designed for maximum efficiency, lethality, and longevity in the most demanding environments on Earth. For over 60 years, aircraft carriers use steam to power their catapults, a powerful but mechanically intensive system. The USS Gerald R. Ford shatters that tradition with the introduction of the Electromagnetic Aircraft Launch System, or EMALS. This is arguably the carrier's most significant technological leap. Instead of relying on immense steam pressure, EMALS uses a powerful linear induction motor, driven by precisely controlled electromagnetic fields, to hurl aircraft off the flight deck. It is the same fundamental technology that powers high-speed maglev trains, but adapted to launch a 40-ton fighter jet from 0 to over 150 miles per hour in just a few seconds. This system is smoother, more reliable, and infinitely more controllable than its steam-powered ancestor. The precision of EMALS is its greatest strength. Steam catapults were a blunt instrument, delivering a powerful but relatively fixed kick. This placed immense stress on the airframes of the aircraft being launched. EMALS, however, can be finely tuned for the specific weight and characteristics of each aircraft, from a heavy, fully laden F/A-18 Super Hornet to a much lighter unmanned aerial vehicle. This gentle, tailored acceleration reduces wear and tear on the planes, extending their service life and reducing long-term maintenance costs. It also opens the door to launching a wider variety of aircraft in the future, ensuring the carrier remains adaptable to new technologies. Gone are the massive, complex networks of high-pressure steam pipes, valves, and water desalination plants that were required to feed the old catapults. EMALS is a purely electrical system which simplifies the ship's internal architecture and frees up valuable space. More importantly, it reduces the maintenance burden on the crew. The sailors who operate and maintain the launch systems are no longer steam mechanics but highly trained electronics technicians. They work in cleaner, safer environments, managing the system through advanced software interfaces. This transition from mechanical to electrical power is a core theme throughout the Ford, making the ship more efficient and easier to sustain during long deployments. The operational advantages are profound. With fewer moving parts and a more reliable power source, EMALS can be reset and fired more quickly than steam catapults. This directly contributes to the ship's ability to generate a higher sortie rate, putting more aircraft in the air faster. In a combat scenario, the ability to launch a strike package several minutes sooner than an opponent can be the difference between victory and defeat. The quiet, smooth, and powerful thrust of the EMALS is more than just a new way to launch planes. It is the sound of a new era in naval aviation, a revolution that begins on the flight deck of the USS Gerald R. Ford. Life aboard the USS Gerald R. Ford is a unique blend of military discipline and the close-knit community of a small town. For the more than 4,500 souls on board, the carrier is home, workplace, and recreation center, all contained within an 1,100-foot-long hull. The daily rhythm is dictated by the demands of flight operations, a 24/7 cycle of controlled chaos that never truly sleeps. Sailors work in shifts, ensuring that the ship is always ready, whether it is 3 p.m. or 3 a.m. The passageways, known as P-ways, are the bustling streets of this city, filled with a constant flow of personnel moving with purpose, from the mess decks to the engine rooms, from the hangars to the bridge. The living conditions on the Ford represent a significant improvement over older carriers, a conscious design choice to enhance the quality of life for the crew. Berthing compartments are smaller, housing fewer sailors, which provides a greater degree of privacy and personal space. Lounges and common areas are equipped with modern amenities, offering a place to unwind after a long shift. The ship has its own television studio, a newspaper, gyms, and even coffee shops. These facilities are not luxuries. They are essential for maintaining the morale and well-being of a crew that can spend many months at sea, far from family and the comforts of home. A well-rested, focused sailor is an effective sailor. Food is a cornerstone of morale on any naval vessel, and the Ford's galleys are a testament to logistical excellence. Culinary specialists work around the clock to prepare over 18,000 meals a day. They manage vast storerooms packed with tons of ingredients, from fresh produce to frozen meats, all carefully planned to last for long deployments. The mess decks are the social hubs of the ship where sailors from every department and rank come together. It is over a shared meal that friendships are forged, stories are exchanged, and the sense of being part of a single unified team is reinforced. It is a brief respite from the pressures of their demanding jobs. Despite the modern comforts, life at sea is inherently challenging. The work is hard, the hours are long, and the separation from loved ones is a constant reality. Yet this shared experience builds a powerful sense of camaraderie. The crew becomes a surrogate family, relying on one another not just for professional tasks, but for emotional support. They celebrate holidays together, mark personal milestones, and face the challenges of deployment as a single unit. This bond, forged in the unique environment of a warship at sea, is the intangible element that gives the USS Gerald R. Ford its true strength. It is the human spirit that animates the steel giant. On the flight deck, there is no margin for error. Here, young sailors in their late teens and early 20s are entrusted with immense responsibility. Consider the aviation boatswain's mate in a yellow jersey, known as an aircraft director. He or she is the choreographer of a deadly ballet, using intricate hand signals to guide multi-million-dollar fighter jets around a crowded and dangerous deck. Every gesture must be precise, every decision instantaneous. A moment of hesitation or a misinterpreted signal could lead to disaster. These sailors depend on their training, their focus, and an unshakable trust in their teammates to keep the operation flowing safely and efficiently amid the jet blast and roaring engines. Deep within the ship, in the quiet, climate-controlled spaces of the reactor department, is a different kind of pressure. Here, a select group of highly intelligent and rigorously trained sailors and officers, the nukes, monitor and maintain the ship's 2 nuclear reactors. Their work is meticulous and cerebral, a world of gauges, readouts, and complex procedures. They are the guardians of the ship's heart, ensuring a constant flow of power to every system. While the flight deck is a scene of visible action, the work of these nuclear technicians is unseen but absolutely vital. The carrier's ability to project power across the globe begins with the silent, unwavering diligence of these few individuals. Then there are the information systems technicians, the digital sentinels of the carrier. In an age where warfare is increasingly networked, their role is paramount. They manage the ship's vast computer networks, ensuring that data flows securely from satellites to command centers to the individual aircraft. They are in a constant battle against unseen threats in the cyber domain, protecting the ship's critical systems from intrusion. Their job requires a deep understanding of modern technology and a relentless attention to detail. The teamwork here is not about physical proximity, but about a shared digital consciousness, ensuring the integrity of the information that gives the Ford its decisive edge. Every job, no matter how seemingly small, is interconnected. The culinary specialist preparing a meal for a pilot ensures that aviator is nourished and focused for a critical mission. The logistics specialist who orders a spare part for a radar system ensures the ship's eyes remain open. The hospital corpsman provides the medical care that gives every sailor peace of mind. On the USS Gerald R. Ford, teamwork is not a corporate buzzword, it is a fundamental principle of survival and success. The ship's advanced technology is only as good as the people who operate it, and it is this seamless integration of man and machine that makes the carrier a truly formidable force. The USS Gerald R. Ford sees the world through a revolutionary set of eyes, the dual-band radar, or DBR. This system is a significant departure from the multiple rotating radar antennas that adorn older warships. The DBR integrates 2 different radar frequencies, X-band and S-band, into a single cohesive system using stationary phased array panels embedded into the ship's island superstructure. This design provides a complete 360-degree view of the battle space without any moving parts, making it more reliable and harder to detect. It is the most powerful and sophisticated radar ever installed on a warship, giving the Ford an unprecedented level of situational awareness. The S-band component of the DBR is the long-range search radar, a powerful eye that scans vast volumes of sky and sea for potential threats. from enemy aircraft and ships to ballistic missiles hundreds of miles away. It acts as the carrier's early warning system, detecting and tracking contacts long before they become an imminent danger. The X-band component provides high-resolution tracking and targeting, capable of guiding the ship's own defensive weapons, like the evolved Sea Sparrow missile with pinpoint accuracy. It can distinguish between closely spaced objects and identify the specific nature of a threat, providing critical information to the ship's combat direction center. The real genius of the DBR lies in its ability to fuse the data from both bands into a single unified picture of the operational environment. This information is processed by the ship's advanced combat systems and displayed for the watchstanders in the Combat Direction Center. Here, sailors and officers monitor a complex tapestry of tracks, identifying friend from foe and making split-second decisions. The DBR's power and sensitivity allow it to see smaller, stealthier targets at greater ranges, a critical capability in an era of proliferating stealth technology and advanced anti-ship missiles. It gives the Ford's commander a clarity of vision that is simply unmatched. This superior situational awareness extends beyond self-defense. The DBR acts as a powerful node in the fleet's network, sharing its detailed sensor picture with other ships and aircraft in the carrier strike group. It can provide air traffic control for dozens of aircraft simultaneously, coordinating their movements for both routine operations and complex combat missions. This capability transforms the carrier from a mere airfield into the central nervous system of a naval task force. The Ford doesn't just see threats to itself, it provides a protective umbrella of awareness for the entire strike group, making every ship and aircraft more effective and more survivable. The USS Gerald R. Ford is far more than a military asset. It is a potent instrument of national policy and a powerful symbol of American commitment around the world. When a crisis erupts anywhere on the globe, one of the first questions asked at the highest levels of government is, where are the carriers? The deployment of a carrier strike group with the Ford at its center is an unambiguous signal of U.S. interest and resolve. Its presence can de-escalate a brewing conflict through deterrence, reassure allies of American support, or, if necessary, project overwhelming force to protect national interests. This floating sovereign territory can position itself in international waters, beholden to no foreign government for basing rights. The strategic value of the Ford lies in its unparalleled combination of mobility, flexibility, and firepower. A carrier strike group can move over 500 miles in a single day, repositioning a powerful air wing to a new theater of operations with a speed that no land-based force can match. This air wing can perform a vast array of missions, from humanitarian assistance and disaster relief, delivering food and medical supplies, to enforcing no-fly zones, conducting long-range strikes against enemy targets, and maintaining air superiority over a contested area. This versatility makes the carrier the go-to tool for presidents facing a complex and unpredictable global security environment. In an era of rising global powers and contested maritime domains, the Ford's role in maintaining freedom of navigation is more critical than ever. The world's oceans are the arteries of global commerce, and ensuring that sea lanes remain open and secure is a vital mission for the U.S. Navy. The visible presence of a supercarrier like the Gerald R. Ford in key waterways, such as the South China Sea or the Strait of Hormuz, serves as a powerful deterrent to any nation that might seek to disrupt the free flow of trade or intimidate its neighbors. It is a tangible reminder of the United States' commitment to a rules-based international order. Furthermore, the Ford-class carriers are designed for a service life of 50 years. This means that the investment made in this ship today will pay strategic dividends for the nation well into the latter half of the 21st century. The ship's advanced design, with its enormous power reserves and modular compartments, allows for the integration of future technologies that have not even been invented yet, such as directed energy weapons and advanced unmanned systems. The USS Gerald R. Ford is not just a response to today's threats, it is a platform built to adapt and evolve, ensuring that the United States will retain its naval supremacy for generations to come. The USS Gerald R. Ford is not merely the next ship in line, it is the first chapter of a new book on naval warfare. She represents a fundamental shift in the philosophy of carrier design, moving from the brute force of mechanical systems to the finesse and adaptability of electrical and digital power. This transition, embodied by systems like emails and the dual-band radar, sets the stage for the future of military operations at sea. The Ford is a platform built for the information age, where data, connectivity, and speed are as important as armor and firepower. She is a networked hub, designed to command not just manned aircraft, but fleets of unmanned drones operating above, on, and below the surface of the ocean. The technologies pioneered on the Ford will shape the entire fleet for the next century. As more Ford-class carriers join the fleet, the U.S. Navy's ability to generate sorties, maintain situational awareness, and operate with greater efficiency will grow exponentially. The lessons learned and the systems perfected on CVN-78 will ripple outwards, influencing the design of future destroyers, amphibious assault ships, and support vessels. The move towards greater automation and electrical power will become the new standard, creating a more capable, more resilient, and more cost-effective Navy that can meet the challenges of an increasingly complex world. The carrier's design anticipates the evolution of warfare itself. The vast electrical power output of her new reactors provides the necessary margin to incorporate future weapon systems that are currently in development. High-energy lasers and electromagnetic railguns, which require immense amounts of electricity, could one day be integrated into the ship's defenses, providing a near-limitless magazine against swarms of drones or hypersonic missiles. The Ford is not a static design, it is an adaptable, evolving platform, a testament to forward-thinking engineering that ensures her relevance for the full 50 years of her planned service life. Ultimately, the USS Gerald R. Ford is a statement. She is a declaration that even in an age of cyber threats and long-range missiles, the aircraft carrier remains the apex predator of the seas, the ultimate symbol of a global superpower. She is a fusion of cutting-edge technology and the unwavering spirit of the thousands of sailors who call her home. As she sails the world's oceans, she carries more than just aircraft and weapons. She carries the future of naval power. The Ford is the dawn of a new era, a glimpse into a future where the strength of a nation is measured not only by the steel in its ships, but by the power of the ideas and the dedication of the people within them.